Let a be a positive constant and the curve C1 is given by y equals to a plus e negative ax, and the curve C2 is given by equation y equals to ln x plus 1. For the curve C1, write down in terms of a, the coordinates of the y-intercept and the equation of the horizontal asymptote. So here, what we do is number one, okay, for curve C, we want to find out the y-intercept. Basically, the technique here is that we know that then you just let x equals to 0. Okay, so let x equals to 0 for one part A, then y is equals to a plus e to the power of basically 0, which is just a plus 1. Okay, so if you let x equals to 0, the coordinates, remember you must write out the coordinates. So at the end of the a, you must write down x equals to 0 and y equals to a plus 1. So you just stop here. So if you just stop here, right, then you don't get full marks because you are asking your coordinates. So answer has to be in coordinates form. Okay, so equation of the horizontal asymptote. Okay, horizontal asymptote, then what you have is basically you try to observe that this equation, number one, is that the function of is that e to the power negative ax is greater than 0 for all x. Okay, can then so basically you can say that for this graph, right, y equals to 0 is a horizontal asymptote. Right, it's a horizontal asymptote because of the fact that this is the exponential graph, right? So you guys ought to know this. So if I'm talking about y equals to e to the power negative ax plus a, so this is like a plus a, right? So then definitely we will also plus a for the horizontal asymptote. So y equals to a will be the horizontal asymptote. And most of you, this question is quite well done. I mean, most of you are able to get it correct, Okay. So next part, okay, I need to sketch a graph of C1 and C2. Your graph should not include the coordinates of the point where the graph crosses the axis, as well as the equation of any asymptote. Okay, so based on what you have, right, you should already be able to obtain this graph. Okay, so you obtain this graph, right, then you are supposed to be able to solve. They are also asking for include the points, okay, the intersect, and you include the points where the graph crosses the axis, which is over here. Okay, and the equation of any asymptotes. Okay, then after that, x equals to -1, 0 and a plus 1. Okay, and you must remember to label the graph. Okay, a common mistake is a lot of you actually forgot that this one has y equals to a as asymptote, and you all actually did it forgetting. Most people forgot to write down the horizontal asymptote. Quite a couple also forgot the asymptotes for x -1. So do take note it's very important that when you draw the graph, you must also have the asymptotes. Okay, so given they told you that they intersect at the point where x equals to 3, show that a satisfies the equation. We want to show that this equation is -3a equals to ln 4 is satisfied. So I mean it's very easy because you are basically looking at this one and this one. So if x equals to 3 satisfy the both of them, that means at x equals to 3, right, the y value of y equals to a plus e negative ax should be equals to the y value. It should be equals to the y value of y equals to ln x plus 1. So it's very, very common sense, because if not, why will tell you what's the point of them putting x equals to 3 there? So that itself, this is the hint. So I just sub x equals to 3. I just sub x as 3. I sub x as 3. You see that on the left hand side you have a plus e to the power -3a. On the right hand side, just ln x is replaced with 3. So 3 plus 1. And there you go. We have a plus e -3a equals to ln 4. Okay. After that, I want to find to 4 decimal places the value of a. So what I can do is, I can just take this, maybe I just put y1 equals to a plus e to the power of -3. Of course, in the question is a, but in your GC, probably what you'll do is, instead of keying a, you can't key a, right? So you'll probably key x. And y2 dash, what you do is just key ln 4, and based on these two, calculate the intersection. We'll just calculate the intersection. Okay, that's all, because you're basically solving the original equation, and the answer should turn out to be 1.3699.